The next thing I'd like to present inside of our IO API will be our file input stream. And here we'll actually start looking at some examples of being able to use an input stream to read from a file. So here we'll actually start looking at concrete classes. So here I want to introduce what is the file input stream. We'll take a look at the file input stream class. We'll look at the file input stream constructors. We'll talk about the steps to read data from a file using the file input stream class. We'll talk about the file input stream methods, and then we'll look at 4 practical examples inside of Java in IntelliJ. The first of which will read a single character. The second will read all the bytes from a file. The third will read all the characters from a file. And the last is we'll read a byte and array of bytes from a file. Now, this is input stream, so keep in mind we aren't reading this as per characters, we're reading this as per bytes. So the file input stream in Java is the most basic file input stream class that is designed to read bytes from a file. In simpler words, it reads data from a text file in the form of a sequence of bytes. That is, it inputs a stream of bytes from a file. So the file input stream was introduced in Java 1, and it's present in the java.io FileInputStream package. And so the file input stream class is derived from the input stream abstract superclass of the file input stream. So it implements closable and auto-closable interfaces. So the general syntax of the file input stream is we have this concrete class file input stream. It extends that abstract class of input stream, the mother of all input streams. And then it has to implement closable because we have to close it, and auto-closable because it also has the option of auto-closing as well. Okay, so the file input stream constructors. So the file input stream class defines the following constructors that create an input stream and read bytes from a file. Its 3 most common constructors are as follows. We can create a file input stream and pass in a file data type. So this constructor creates a file input stream from a file object in the file system. Or 2, we can go ahead and invoke the file input stream constructor and pass it a file descriptor data type. So this form of the constructor creates a file input stream by using the file descriptor object. And then finally, we have a constructor file input stream where we can pass in a string, which is the file name. So this form of the constructor constructs a file input stream using the file name, which is the file pathway. So if we try to create a file input stream with a non-existent file, we will get a java.io.file-not-found exception that will occur. Okay, so the steps to read data from a file object using the file input stream class is as follows. First, we need to add a file to a file input stream. So we can use one of those 3 constructors. Suppose that we're using the third constructor where we're going to go ahead and use as a string the file path that our file is at. So we'll pass that in as a parameter, then we'll invoke the constructor for file input stream and save that into a variable. So here, this file input stream object enables us to read the data from a file in the form of bytes. So 2, the next step is to read data from a file. We need to call the read method using the file input stream object reference variable. So the syntax is as follows. We have that data, that variable we made earlier. We can invoke the read method and get back cars. So get back that data from the read method. So once the read method reads all the characters from a file, it will read the end of the file, and -1 will be returned if there's no more data available to read. So if you want to think about this in terms of a diagram, we can look at the figure to understand the 2 steps for reading data from a text file. So we have my file. So then we're going to open up the file as a file object and then load it into the file input stream where we can read it. And then if we wanted to do something with it, we create a file output stream where we can then write data out to the console out to the monitor. So we can read from inside a file and then display it onto our monitor. So our FileInputStream Methods class does not define any new methods. All the methods in this class are inherited from the input stream, and the most common inherited methods from input stream are as follows. So again, the available method. So the available method is used to get the number of bytes that can be read or skipped over from the file input stream without blocking by the next invocation of a method for this input stream. We have a close method. This method closes the file input stream and releases any system resources associated with the stream. We have the ability to get the FD, the file descriptor. This method returns the file descriptor object that represents the association to the actual file in the file system being used by our file input stream. We have a read method. We have three read methods, right? The ability to read a byte of data from the input stream. We have the ability to pass in a byte array where we can read up to b.length bytes of data from the invoking input stream into the array of bytes. And then we have the ability to pass in these three parameters, the byte array, an n, and an m integer. And here this reads up to m bytes of data from this input stream into that array of bytes from the nth byte in the input stream. And finally, we have the ability to skip, where the method skips over and discards n bytes of data from the input stream. So almost all of the methods in the IO stream classes throw an exception named IO exception. This exception is thrown when an input-output operation fails because of an interrupted call. Therefore, we need to declare to either throw a java.io.io exception in the method, or we put our code in a try-catch block, right? Because an exception, an input-output exception could potentially occur. It could produce exceptional behavior. This is a risky. Every time we try to read from a stream, we could fail from that. So we have to pre-plan for that failure. So this is where we start having these checked exceptions that we kind of mentioned in Unit 1. Okay, let's actually look at the examples. Let's look at example 1, where we might want to read a single character. So let's take an example program where we will read data from a file called myfile.txt using a file input stream, and we display it on the monitor. Before doing coding first, let's create that file named myfile. So inside of my file, I'm going to have it say, welcome to UNO Computer Science. And then after that, we're going to go ahead and examine this source code. So let me jump on over to my IntelliJ over here. And let me open up my example 1 here and also my file. So I have this file. It's called myfile.txt. It's inside the same directory as all of my source code files, right? So it's in my src directory, my source directory, and it just says, welcome to UNO Computer Science. And then I have a new line character, so it's 2 lines technically. So in my file input stream, tester 1, I'm going to go ahead and import my java.io file input stream class. Then I'm going to create a class that we can go ahead and create a file input stream tester so that we can make a main method. So here's my main method. Since using file input stream, just trying to create a file input stream is risky. It causes a checked exception. Then I have to do this in a try-catch block because I need to be able to catch any exceptional behavior from attempting to open up this stream in case I gave it the wrong file path or whatnot. So here, I'm going to attach a file to the file input stream for reading data and create an input stream for that file. So I'm going to call the constructor that's going to take in the file path as a string. So I'm going to use / that says from the current directory that my Java file that the JVM executes from. I'm going to go into the source directory, the src directory, and inside that directory is my myfile.txt. Perfect. So it's going to open up that file, and then it's going to effectively allow us to read it using a file input stream. Then what I'm going to do is I'm going to invoke read. And in fact, let me run this so we can see what's going to happen. And I'm going to save that value from that single read. And so that's going to read a single, it's going to read a single byte from me. So I'm going to be able to encode that as a W. And then I'm going to display the value inside of here. And then I'm going to, and so the integer value is 87, right? So it's reading the value returned as a byte. So we'll convert that into a decimal value. And then what I'm going to do is I'm going to take that byte and I'm going to cast it into a character. So it's going to take the numerical decimal value. And so then I'm going to encode it into a letter. And I'm going to print that out. And that's going to print out W. That's the W from our welcome. And then I'm going to close my stream. Oops, don't want that. And if any exception were to happen, that would print out the exception. And clearly I got the numerical value from my read and then casting that value into a character, into a car. Because remember, a car isn't Unicode. A car itself is is 1 byte. So it allows us to translate a 8-bit formatting of our most basic of ASCII keys into a character representation. Okay, perfect. And so that is our output that we got. Okay, so for the next example, let's create a program where we read all the byte values from a file and display them on the console. So again, this is just a small, simple program. It's going to use that same file, this one right here, myfile.txt. So I'm going to import my java.io FileInputStream class. And then I'm going to create a class that has a main method. So I can go ahead and execute code. Since any type of opening up any type of streams is potentially risky, it can cause a failure. If for some reason it couldn't generate the file object, it creates a checked exception. So we have to use a try-catch block. So inside my try block, I'm going to try to create a new file input stream using that path as a string .crc.source, effectively slash myfile.txt. And then I'm going to save that into this variable, this file input stream variable. Then I'm going to read all byte values from the file and display them on the console. Let me go ahead and run this so we can see what this looks like. And you can see it's going to do all the byte values. And so here we're going to start I'm going to set my value to 0. That's going to be my sentinel value that I'm going to use to determine when my while loop ends. Recall that when I do a read command, the read command is going to go ahead and return back the integer value of that byte or -1 when we're done. So we can do kind of this wacky thing here where I am going to evaluate the value here, and I'm going to set it to whatever this read is. And so long as my read does not produce a -1, I will go ahead and continue this loop, and then I will just print out the value here. And so I'm going to read the value. I have a value, so it's going to print out that 87. That was the W, right? And then the 101, that's the E, and then it's going to keep printing out all these values until it hits the end of the text file. And when the text file has no more bytes in it, it's going to return the -1, and then my while loop stops. And then when I'm done reading, I will close my file input stream. And then here, as a result, I'm going to individually read all of the bytes from my file and report them in their byte format. And if I wanted to, I could cast those into characters. But right now I'm just displaying them as their integer value. Perfect. And again, -1 represents the end of file. We usually refer that to as EOF. And then for the third example, let's see if we can't read all the characters. So again, we're going to do something relatively similar to what we just did before. Let me run this so we can see here, you're going to see we're actually reading the text file. Welcome to UNO Computer Science. So I'm going to import that FileInputStream class. I'm going to go ahead and create a class so I can have a main method. Since using a file input stream is a check, causes a checked exception, we always have to do it in a try catch block. So inside my try block, I'm going to try to create a new file input stream, and I'm going to pass in the path as a string of where my file exists at. And then I'm going to save that into this file input stream variable. Then I'm going to create an integer value of my value. I'm going to do that same process of reading all of my values in, read a value, bind it to value, and so long as it's not -1, I'll take value. I will then cast it into a character and then print it out. So it'll take the decimal representation and then map it to a keyboard character to be able to print out. And then when I do hit a -1, I've hit the end of file. So then I will close my input stream. And of course, because I have a try block, I have to have a catch block. And all I'm going to do in my catch block is do a system.println in case an exception occurs. I'm not expecting any exceptions to occur. And then finally, the very last example for the file input stream is, can we go ahead and just read a byte or even an array of bytes? So let's create a program where we'll see how to read a single byte, an array of bytes, and a subrange of an array of bytes. And we'll also determine the number of available bytes remaining using the available method and the skip unwanted bytes by using the skip method. So here we'll look at some of the other methods we hadn't seen in the prior examples. This is a little bit bigger, but we're just making a lot of small superfluous calls. So here, what we're going to do is we're going to go ahead and import our file input stream class. We're going to also import our IO exception class in case we do throw an IO exception, we try to catch it. We're going to create a method that allows us to define a main method. And here we're going to import this class to show you a different way of being able to use the file input stream. In the prior 3 examples, we had a try catch block. So anytime we tried to do an operation where we created an input stream and operate on that input stream, we had that in our try. Another way we can do this is just have our method that's doing all this exceptional, potentially exceptional behavior to throw itself an IO exception. And so this just kicks that can down the method call line, where if we were to encounter IO exception, instead of trying to handle it inside of our own method, we would just throw that exception up to the next method that's invoking us. So this allows us not having to manage it in any kind of way. So because of that, we don't have to do the try catch block, but we're also not being responsible with the IO exception, right? We're just forcing someone else to have to manage that responsibility. So not necessarily the best way, but an easy and dirty way of doing that. So here, we're going to create a new file input stream. We're going to pass in the path and we're going to save that. Then we're going to use, and let me run this so we can look at the output while I talk about this. So we're going to go ahead and say, hey, how many available bytes are inside this file from the time that I first open it? And it's going to say, oh, the total number of available bytes is 32. So that lets me know how many bytes I could potentially read or skip or whatever else I want to do. And then I'm printing out the size of the byte. Then I'm going to set my end value, the number of bytes that I want to be able to work with, to 2. So here I'm going to create a for loop. So n is equal to 2. So starting at 0 until my indexing, my iterative, my loop control variable here, it hits 2. So this is going to run twice. I'm going to do 2 reads. So I'm going to read the first 2 characters, and then I'm going to convert them into character data types so we can represent them instead of as integer numbers, instead as letters. So here I'm going to print out a byte at a time for the first 2 bytes, WE. So that's my welcome, right? And I read that off of my file input stream. Now I'm going to query my file input stream. How many bytes are now available? Well, we read 2. So now it's going to say, oh, I still have 28 bytes left inside of my input stream. So notice my input stream is tracking. It's got like a cursor that lets me know how far into it I've read. And as I pull those values out, as I pulled the W and E out, I'm sorry, 30. I went, so I have 30 values. I have 30 bytes left I can read in there. So as I read, it's mutating the file input stream. It's removing the W, it's removing the E. So now it only has 30 bytes, and the starting value would be the L. So then what I'm going to do is I'm going to create a byte array, and I'm going to create a new empty byte array that can hold up to 2 elements, 2 items. Then I'm going to read, and I'm going to use that overloaded method where I'm going to pass in that empty byte array into the read method, and it's going to go ahead and read until the length of that byte array. So here we see it's going to read the L and the C. And now if we go and look at the size, the available bytes, it's going to be 28 inside of my file input stream. And now what I'm going to do is I'm going to create a new string using the byte array and giving it from the index to 2. And so I'm going to print that out. And so that's going to print out the L and C here. That's where the LC is getting printed out. So notice you can use the string constructor using an array of bytes. You probably haven't seen this before. And then we can specify on our array where we want to start, where the offset, where the starting point is, and then how many consecutive bytes to read in. So we're just doing the entire thing. Okay, the next thing we're going to do is we're going to skip half the remaining bytes using the skip method. So here we'll take the size, we'll divide it by 2, and then we're going to skip that. So here we're skipping, and what we have now is the available number of bytes left is now 12. When we look at what is left in our file input stream. So here we're going to read that. And so reading 1 from the end of the array, LT. And so here we're reading 1 from the end of the array. And so when we read our byte array, we can have that offset, and we can have the number of variables, and we continue to read using the 3 parameters until we hit the end of our size. And then finally, the number of bytes we have after we're done processing this offset, doing this read on a subarray of our bytes, we would still have 11 left because we only read 1 from the end of the array. Excellent. So that's just an illustration of how we can read a single byte, how we can create a for loop to read a byte at a time, how we could use a byte array and read everything into the byte array and then display that, or how we can then use the read method and read a sub portion of a byte array and then write that out, how we can then put that into a string and then print that out. Excellent. And so those are just the 4 examples of the file input stream that I'd like to go ahead and share so you can actually see some actual code.